So my talk is about Zepto, a mobile JavaScript framework that's jQuery API compatible. Not all of it, but most of it. And I will also talk about micro frameworks in general and why I think they are a good idea. So first off, this is a real computer, right? So what does a real computer have that a mobile device hasn't? Any ideas? Lots of memory. A hard drive, a spinning hard drive. I actually don't have a spinning hard drive in my computer. Full-size keyboard. So there's a lot of differences. I think the main differences are it has a fast and stable network connection most of the time, especially at JSConf, because Cramforce and team has done a really great job with the Wi-Fi. So a round of applause for them, please. It's really hard to get this right, and it's pretty amazing. Anyway, you have lots of storage, lots and lots and lots of storage, and you have fast multi-core CPUs. You also have multi-core CPUs coming up in mobile devices, but even if it's a multi-core CPU, it's still much, much slower than anything you have in like a real computer. And of course, you have hardware-accelerated graphics. Most browsers these days support like some form or other of hardware-accelerated graphics, even if they do not composite themselves in a hardware-accelerated way, like use textures to render the DOM elements. They do use the operating system provided like low-level hardware-accelerated methods to render the stuff. So what about the mobile devices? So what do they have, or what do they not have? Any ideas? Battery life? Pooping restrictions, right. I mean, actually, the iPad, I mean, it's probably used most often while pooping, I think. So, not talking about my experience here, by the way. So they have a slow and unstable network connection most of the time. If you have like an AT&T mobile phone, like my phone is, it has a slow and unstable network connection. It doesn't have so much to do with like the phone itself or the technology itself. It's just that in the real world, like other people use it, like the same connections that you use, or you're in like the shadow of a building and the connection doesn't get through to you, blah, blah, blah. The end result is it's unreliable. You also have limited storage, you have slow CPUs, and hardware acceleration right now, for browser stuff at least, is only available on iOS. The other browsers have the other devices all use software rendering and compositing, so it's kind of slow. There's an interesting thing about this. Like, all major JavaScript libraries first came out when we had phones that looked like this phone. You may have had it. It's a Sony Ericsson T610, I think. I had this phone for a long time, before I had the first iPhone. I think this phone came out in 2003 or something. But most phones from like the middle of the first decade of the 21st century are like this, like color screen, lots of buttons, really awful web browsers, if there even is a web browser on there. So JavaScript libraries really were written with the real computers in mind. And now, because we have mobile browsers that do so much more and are almost like desktop browsers, we use these JavaScript libraries on the mobile devices. And maybe it's sometimes not the best choice. Like the movie that I will show now will demonstrate what happens if something's not the best choice. You recognize him? It is David Hasselhoff. I think they really tried hard to make it really awesome, but something really went wrong while they did the movie.
Look out!
So this little video, it proves two things, I think. The first thing is there's nothing that doesn't exist on the internet. The other thing is that don't just use something because it's popular. Don't, I don't know, use David Hasselhoff in your code because he's popular. I don't know. It's a weird argument. Anyway, use things that are the right tool for the job. Use the right actors for the movie, or use the right frameworks or the right codes for your codes. So again, there's a commonality between those devices here. Each of those devices actually uses WebKit in their browsers. There is like Firefox now for Android, but all of these devices come with a browser that's based on WebKit. And it's very interesting, and we had some talks earlier at JSConf that talked a little bit about this. It's very interesting that WebKit has a lot of proprietary features. It's like the new IE6, right? But actually, IE6 came with a lot of features that were really awesome. IE6 and the IEs before IE6, actually. And I think people don't realize that enough. Anyway, proprietary features are actually mostly adoption of features from various JavaScript frameworks. And that's why it's so important that we have awesome JavaScript frameworks. And that's why it's also important that we have a diversity of JavaScript frameworks. It's not good to have a monoculture. It's not good to have just one framework that rules them all. It's good to have a diverse landscape of frameworks for various uses. Like if you use jQuery, go with that. If you need Dojo, go with that. It's like, use what you like best. However, for mobile, there are a lot of restrictions in this. Anyway, proprietary features are awesome. Really awesome. So here are some of those features that you might not find in a desktop browser. The first feature is CSS selectors. Dan mentioned it during his talk. Document.query selector all. That's awesome. Basically, this one line of code replaces about like 6 kilobytes of gzipped and minified CSS selector code that you would need with a classical library. Of course, it doesn't do exactly the same thing, but it does the same thing for most intents and purposes. It's full-feature CSS-free selectors that are just built into any WebKit. You can just use this and you get like a node list out of the call. Node list is a JavaScript array-like structure. You can convert it to an actual array if you call array.slice.apply or array.prototype.slice.apply, or just you create an empty array, say .slice. And it's more or less doing the same thing that like Sizzle does, right? And there's other JavaScript-based CSS selector engines actually. So query select all, full features CSS selectors. Most importantly, it's not that it's full feature CSS selectors, it's really important that you don't need any JavaScript libraries to use that, it's just there. It's also important that it's faster than any JavaScript libraries can ever be, because it's just C code. It's pretty optimized because it basically reuses the same code that WebKit uses to style the page and to parse the CSS and stuff. So it's just there, sits there. It's just an DOM API interface to that engine, CSS select engine that's already in WebKit anyway. Next feature, JSON. Native JSON support. Also, if you have to support like older browsers on desktop, the thing is, you have to have some external library that provides this functionality. There's the JSON stuff from Douglas Crockford. You can use that. But however, on WebKit, on the mobile devices, it's just there. So just use it. JSON parse, same thing. It actually has a lot of advantages to use this native stuff because, first of all, like all the security problems that you would have with like eval, like taken care of. And if you use like normal JavaScript code to pass JSON, you have to run it through like a series of regular expressions, which is, let's say, not the fastest way to deal with that. So if you just use the native implementation, it's faster, shorter, less code. Don't have to download anything. So you just win by using this. And this stuff is not only about DOM APIs and DOM proprietary features. It's also about JavaScript features, of course. And WebKit supports a lot of the newer JavaScript features, like the for each iteration over an array. If you haven't done that, array with 3 numbers. For each is a native function on arrays. It's taking a function argument, and so if I feed it alert, it will just call window.alert, which will do this. It's very easy to understand. The enumerable APIs have a lot of advantages. There's not only for each, there's also filter, map, reduce, other APIs that you can use, which would normally in a browser require an external library like prototype.js, for example, supplies a lot of these enumerable functions, or you can use underscore, which is basically an extraction of the prototype.js goodness to be used with any JavaScript library or with no JavaScript library at all if you want that. So if I combine this stuff, so I take the results from the document.querySelector all call and like stuff it into the for each loop. You can say that you can see that I can combine the DOM API and, improvements and the language improvements, of course. So array iteration has a lot of advantages, as I said. Among them are you no longer need any for loops. I really don't like for loops. And the other advantages are, as you can see, really, it makes it so much easier to read the code, write the code. It's just a good thing. So for a mobile JavaScript framework, as I explained, there's a lot of stuff that's in WebKit already, but there's some other reasons I think that's, let's say, that you should probably not use prototype, jQuery, or Dojo or whatever, like these big frameworks that are around. And there's some quite interesting reasons. Like one reason is that not all of the functionality in these libraries is even meaningful on a mobile device. For example, a mobile device, it does not resize its windows because it's always full screen. However, it does something else. It has an orientation change event. So you can see even though the like base libraries like jQuery or prototype are not really like completely designed with like a desktop browser in mind, they do have some assumptions in place that are just not valid on a mobile device. There's some other things like, for example, on iOS, in the iOS browser, if you focus a form element, the keyboard will automatically like flip up on the screen at all times. And that's one thing that's just there, which is a surprising side effect of using a mobile device. Like you focus an element, but at the same time, focusing on an element means that half of your screen is gone suddenly. So, and that maybe the browser even like scrolls around your page, so that you don't have that on a desktop computer. Of course, more code causes longer download and initialization times. The download times especially are a problem. If you have like a slow edge connection maybe, somewhere, if you download jQuery or prototype, both libraries are pretty much the same in size, like about 30 kilobytes gzipped and minified. That can take like 10 seconds on a slower connection. That's 10 seconds, the user stands there, like in the rain, waiting for the cab, like getting pissed off about your website. Try to accommodate the user and try to make your site load as fast as possible. The thing is that most of the downloaded code isn't even used on the mobile device. Like, lucky us, there is no IE6 on mobile phones. I hope there are no plans for that from anyone. I will kill them personally. Yeah, you laugh, but there's actually this company who makes like a plugin for, how is this going? It's a plugin for newer IEs to run the IE6 engine to support like legacy applications. It's just horrible. I mean, it's like, it's really, really weird. Anyway, a lot of the code is also duplicating features that are actually directly available as native implementations, like the CSS selector engine, like maybe like array enumerable functions, any like polyfills you have. Actually, maybe not necessary because all WebKits on the mobile devices support a certain set of like enumerables, function, and JavaScript stuff, and DOM API enhancements. So just don't roll it out to your mobile clients. So what would be the goals for a mobile JavaScript framework? The first goal is that it's optimized for short code size, because the most important factor in this is that it loads as fast as possible. The initialization times are also interesting. The less code you have, the less code has to be evaluated when it's actually finally made it through the wire, through the mobile browser. The mobile browser evaluates the code, initializes everything, maybe applies polyfills. For example, there's some like differences between iOS 3 and iOS 4. You need to patch some stuff up there. But if you keep that short, your page will load faster. The JavaScript engines on mobile devices are not yet as fast as the JavaScript engines on a desktop computer. It's quite optimized already. Apple was just releasing OS 4.3 with like a lot of optimizations for the JavaScript engine in Safari. Like it runs twice as fast or something. But still, it's a long way to go. So the shorter the code, the better. And finally, another goal would be that you have an easy-to-use API in your mobile framework. For example, by emulating jQuery, because developers already know it and like it. It's a good API for DOM manipulation, so why not use that? There's no reason to reinvent the wheel for this. The mobile device is still HTML and DOM nodes and CSS stuff. You'll need this approximately the same stuff. And you want it to be easy to extend and customizable. Again, jQuery has a very easy to use concept for plugins. It's often app used, but often it's really useful. And we want to support it too. And finally, you want a fallback mechanism. Basically, if you run your mobile web browser, mobile website or app on a mobile browser that's not WebKit, you should just be able to include like jQuery proper, because it provides the same API, and it will make sure that it runs there. However, the users will have to download much more code. So it's really not so important what's there, but what's not there in the code. So meet Zepto, if you haven't used it before. It's on GitHub, github.com/mattRobbie/Zepto. I'm Matt Robbie on GitHub for historical reasons. It's weird. So it has a target size of 5K. That's minified and gzipped. I think 5K is a good size that you can still transfer fast, even with a slow connection. It's very cacheable. There's no problems with any like caching limits, like older iOS versions at least have like really weird caching limitations. It has a jQuery compatible API. It doesn't mean that it covers all of jQuery, but it covers a lot of jQuery. It uses mobile WebKit features whenever it's possible. And that part is important. That means that it, for example, doesn't really work on Firefox. And it's easily replaceable with jQuery proper if you need to do that. To give you an idea of the size difference, this is jQuery 1.6. It has 31.33K gzipped and minified. I did this just yesterday with Uglify.js and the command line gzip compression tool on the highest setting. So it's a fair comparison, I think. Of course, mind that Zepto does not cover all the features that jQuery has. It covers a lot of features, but you can see that it's a lot less to transfer to the client, and that's the whole goal of the Scepter framework. To show some code too, this is the main $selector function in Zepto. Just ignore all the stuff that's up there. It's lots of special cases because the jQuery API defines a lot of special cases depending on what thing you stick into the $function. If it's a string, it has to check on certain things and do certain stuff. If it's a Zepto object itself, it does behave differently. If it's a selector string, it will eventually call the selector engine, like down here. So there's a internal function in Zepto that documents selector signature. So in Dan's talk, he mentioned that Ender.js has this feature where you can just swap out the selector engine. It has the same call signature. So even if you say, I want to use Zepto, but I need a better selector engine because I want to use these advanced features that I do in jQuery or whatever, you can just stick in Sysl and connect it to this function and you're good. Again, it's really pretty simple. The query selector all call with the selector, and it's converted to an array. And this saves about 6K of selector engine code, depending on what selector engine you use. There's several selector engines actually in JavaScript with various feature sets. There's one engine that's about 1K in size, but it only supports CSS 1 and 2. And most of the engines that support CSS 3 are 4 to 6K or 4 to 8K in size, minified and gzip. So here's an instance where Zepto uses something that's kind of WebKit specific or at least non-standard. I mean, it would also work in Firefox, this thing. So what it does here, it's setting the proto, the __proto___ property of the object. So this is done so the query selector all call returns a node list, and we convert that into an array with the array.slice call. And however, we do want an array-like object, but we want it to have all the stuff that's in $fn. So what we do, I just swap out the prototype of the array, under its S, basically. And you end up with an object that looks like an array. It has a length property, and it has all the other elements that we found earlier. So it has a 0, a 1, a 2, a 3 property, etc. But it gets all the prototype, the stuff from the set.prototype thing, which is identical to $.function. So without copying anything around, it's just switching this out, and this is pretty efficient. Yeah, the set.prototype is just pointing to $.fn. So $.fn, if you use jQuery, you can just stick stuff in there. It will appear on all your results. This works fine with Zepto too. A side effect of this is that you can reuse array methods because it looks like an array. So yeah, basically get all these methods for free on any Zepto object. It's still a Zepto object, but we kind of abuse these array-provided functions. Works fine with the Zepto object too. This inside of the Zepto object, inside a function call, this is the implementation of the is API call that you might know from jQuery. That this inside the function corresponds to the current Zepto object, and you can index the results there, like with 0, 1, 2, 3, etc. Or this.length returns the number of nodes found in the Zepto object, but you can also directly call these functions on stuff too. One instance that's interesting is the implementation of before, end, after, begin. So of append, prepend, before and after. because this uses something that's actually proprietary to Internet Explorer, and Firefox does not support this, but it also works on WebKit. So WebKit, for some reason, at some point, they decided to implement this IE-only API, and it works fine. It works really great. It's in the end, it's less code than I would have used if I implemented that with like the document fragments API stuff. So it's one point where IE actually provides some cool value to mobile stuff. So Zepto, again, CSS selector, DOM manipulation. It has full Ajax support, including cross-domain JSONP. It has events, including some touch event support and gestures. It has some polyfills. Polyfills are awesome for older WebKits that don't support certain JavaScript API functions. It's very modular, so you can just include the core of Zepto, and which is about half of this 5K target, if you just wanted DOM manipulation. If you don't need the events, for example, or if you don't need the Ajax, you can just leave that out, etc., etc. It's WebKit only. I stress that because I constantly get emails, when will Scepter work on IE? So answer to that is, it's never. Or when IE uses WebKit as its rendering engine, so never. But, I mean, the question makes sense, but it's really restricted to that. And that's why it's so small. If you want to support other browsers, just use jQuery. It's that easy. So some examples of people that use Scepter right now. The most prominent example probably is Basecamp Mobile. They use actually a really interesting combination of, first of all, they use CoffeeScript to develop everything, but they use some external libraries. So they use Zepto, and I think they use Backbone, and they also use some other stuff they wrote themselves, which is not open sourced yet, but I think they will open source it. So that's pretty cool. And you can see it works across all of these devices that have WebKit browsers. Another example that we saw earlier today is the new mobile website from Zappos. Also pretty cool. I hear that eBay and JSConf will base their mobile versions on Zepto. JSConf is a pretty big provider of e-commerce software. For example, they do the Toys R Us stuff. The mobile checkers website uses Zepto right now. It really wants me to eat a burger right now. Burger, please. And of course, your project could use Zepto. This is a project from a Swedish bird watching application thing. Like I think it's a social network for bird watchers for mobile devices. So you can say, I saw this bird here and here. It's kind of cool. It's like, I mean, it's not my thing. I don't like to sit in a bush for 5 hours but it's awesome. And that said, that brings me to my to maybe the main point in my talk, actually. So Zepto is cool, but Zepto is really only a subset of jQuery with some less code. That's it. It's really that simple. And I couldn't help it. But so I think we saw it a lot of the time. So and now it's a little bit time to nerd out. So we have all these amazing frameworks, right? Like Scriptaculous. Prototype JS, right? jQuery. Maybe even MooTools, right? So, and I really think it's time to give like the micro frameworks a little bit of room in everyone's like toolkit, and micro frameworks are awesome. So the micro frameworks are basically like evocs, kind of dumb but useful. Like they can kill stormtroopers pretty efficiently. So you're the rebels, right? And you have your evocs, micro frameworks. to slay the evil empire, which are the users. No, just joking. And while we're at Star Wars, made this slide. It has nothing to do with my talk, of course. It's kind of true. So, classic frameworks try to do all things and do it kind of okay-ish. They have drawbacks, like, for example, performance, size, and stuff. Classic frameworks also force you into an API. If you use jQuery or Prototype, they basically force you to use the API everywhere, right? They might not be modular, not modular. Why does it say not modular enough? I have no idea. Like Prototype, for example, is completely not modular. jQuery is not modular. MooTools is, for example. So some classical frameworks are modular. They have in common that they have like 25K or even much more minified and gzip. That's the size of those libraries. If you use jQuery or Prototype or MooTools, I don't know about MooTools actually. A lot of these classical libraries are much larger than this, of course. And the problem is, as you have seen, a lot of the stuff that they implement is actually now part of the DOM or JavaScript or the WebKit browsers or Firefox or whatever. Because the browsers adopted the features from those libraries. So it doesn't make sense for the libraries to push that out to clients anymore. We can remove the stuff from the libraries. And this is where the micro frameworks come into play. They are awesome. So micro frameworks, in my definition, is they do one thing and they do it really well. They should be smaller than 5K. That's like a completely made up number. So if your micro framework has 7K, don't shoot yourself, please. Some people would say micro frameworks cannot be larger than 2K. If you're on the extremist side somehow. You can use them directly or loosely coupled. A micro framework should not have dependencies on anything. Of course, there can be micro frameworks that are written specifically for some other framework. It's like, in that kind of sense, like many jQuery plugins could be considered a micro framework. I don't consider them that. I consider them plugins because they are. It's a hard differentiation to make. Small is beautiful, right? Easier to understand code and to fork the code. The few lines of code you have in your micro framework, it's like every line of code that you save makes it easier for other people to understand your code. Most of the time. I mean, you can also like submit your entries to JS1K. No one will ever understand your code. But that's like an extreme example. Every line you save in your code will probably make your code download and run faster. Every line of code you save leads to fewer bugs because less code equals fewer bugs. Because that just cannot, not as much things can go wrong with your code if you have fewer lines of code. And plus you will understand how JavaScript really works because if you write a framework with no help from other frameworks, you will be forced to understand JavaScript, which I think is a good thing because we all should understand JavaScript very well. I mean, we are JSConf. So here's some examples. Mustache, it's 1.5K in size. It's awesome. Launcher, it's 2K. Launcher is pretty awesome, actually. You should check it out. Backbone, it's about 3.9K. There's also several other implementations of like similar MVC client-side frameworks. Personally, I'm really not a big fan of MVC client-side stuff. I think it's in a lot of cases it's not the right choice to use. But there are cases where you need it, and there's several options. So the problem is, how do you know what is out there? How do you discover what micro frameworks are available? Like you cannot like check through every GitHub account, right? And that's why I'm announcing today. I'm launching a website called Micro.js. So you can go there right now, microjs.com. It's a really dumb list of awesome, amazing micro frameworks. You just say what you want up there, and then it will show you micro frameworks that might fit your needs. And you can fork the project at github.com/robbie-microjs.com. That URL will go live after my talk. And you can, there's like a data file. It's really simple, it's 2 files, index.html. There are no images or anything. It's all CSS-free goodness. And there's a data.js file where you can just add your library if you want to use it. That's it. Any questions? So the question is, I extend my object with array functions. The reason why I don't use like a check if it's already existing, right? That's the question. No?
The check would be if the property would be inherited from the array prototype and not so much from object.
So the thing is that because I swap out the prototype, like the array stuff is gone. So only the properties of the object are still there, but none of the properties from the prototype it had earlier. So all the array stuff is gone, so I just need to add it back in. Okay, so you're asking why I don't just add all of the array, right? The reason why is because some of the jQuery API names are clashing with the API functions. For example, filter. So I need to manually select what I copy over. So Brandon's question is, why the hell am I using the __proto__. So yes, it helps in code size, but I think it helps in speed because I do not have to manually copy like stuff around to because I already have an array and I want an array like structure later. So I just swap out the prototype and it works fine. Works really, really efficient also. Brandon also says the insert adjacent element is coming in Firefox, so soon it will be Firefox mobile compatible, I hope so. So I think, yes, I would take patches to make it work in Firefox. However, it would be good to provide that like as an add-on. So in case you don't need to support like Firefox mobile or whatever, you can just use the basically, I think there's already a patch in there somewhere. It's like a polyfill for Firefox to support the proprietary feature from IE, the insert adjacent HTML or element function. So that would be a good like add-on for it. But I don't think most people that use it actually need to do that. You know what I mean? It's really, the lights are extremely bright. If you stand up here, it's kind of crazy. Any more questions? No, that's it. Thank you.
Happy trails to you until we meet again.